Hi, my name is Serge MONROS. I'm the CEO and founder of Savicorp. This is our corporate facility here in Santa Ana, and I'm going to give you a tour of every stage of the process of what we do here. This is the staging area. This room here is a staging area where we bring vehicles in, we check original parameters anywhere from the way the engine runs, all the hoses and all to make sure that everything is running properly, and we also do emission testing, and we document all the OEM parameters, which means original equipment manufacturer's parameters. Next, we're going to go to another room, and I'll explain what we do in that following room. In this room here, we put the dyno valve kits together. They're manufactured outside. We bring them in here, and then we actually package them here, warehousing them here. And we also have a special R&D room. We have mechanics. To my right here, there's the workbenches where the mechanics work out of, and also we do small prototype R&D. Behind me, there's some cubicles. On half the cubicles, we do the CAD work. So once we finalize the product, we completely do a set of blueprints. They're all electronically done, and then we also do quality control, schematic diagrams, and also any type of prototyping that has to be done for any type of new vehicle or new system that we might build. Like if we want to put it on a Harley, we would bring a Harley in and retrofit it, blueprint it, and then have a kit ready and available for it. In this room, we do retrofits. We have a new product we're going to be introducing pretty soon. We did introduce it in the open house, but it's not going to be introduced to the public for probably a few weeks. We'll let you know as soon as we're ready to. So we do those retrofitting kits. We're getting certification on that product. But behind us, you see 4 lifts, and those lifts are made for installing dyno valves. We also do water repair here because some of the vehicles that come in for an installation might have inadequate hoses or wires, and we have to fix them before we could actually install the dyno valve. Behind me, all the way to the wall, is a machine shop, small machine shop. It allows us to make small parts, fabricate small things that we need to do these retrofits. This is a dyno room. In here, we have dynos. We have 3 different types of dynos here. We have one to my right, which is for older vehicles, 2000 and older. The one to the left is for newer vehicles, and the one in the middle is for motorcycles. There's a room behind me which is a Hariba equipment, which controls the dynos. What these dynos do is when we do 3 baseline tests with the vehicle that we want to certify, or a class of vehicles we want to certify, we'll put the vehicle on a dyno. We'll do 3 baseline tests with the OEM condition, meaning we don't touch the vehicle, just prep it. And then what we do is put the dyno valve into the vehicle, and then we do 3 tests while it's considered modified with the dyno valve. And then these tests put the engines under a certain strain. The rollers then rotate, and it puts a resistance against the rear, or front wheel drive, it puts a resistance against the axle and the tires and the engine. So the dyno simulates going up a hill, simulates different driving conditions, windy conditions, and what this does is it actually simulates road conditions, and then when a vehicle is put under a load, it pollutes a lot more under a load than it would just sitting there idling, or just sitting there idling while you accelerate. So what we do is there's a bunch of parameters that come out of this. So as you're testing these vehicles, you get a lot of data. And this data could be then deciphered, and because we have an electronic controller on our device, we could then program and change the program inside the controller to maximize under which operating condition parameters in the computer, so then when the car is on the road, a controller for our dyno valve could react according to the conditions that it was pre-programmed for from this dyno room. This is the shed room. I'll give you a little bit of history. Back in 1994, or 93-94, we were getting the executive order, our first executive order for OBD1, and back then we had a choice of doing 300 cars or do the cleanest and the dirtiest in America, which turned out to be the Ford Taurus, which was a 93 Ford Taurus, which had LEV emissions, which is low emission vehicle. That was for the year 2004, and it had this back in 1993. And it was a very efficient engine. It was 3.0 V6 and got 39.6 miles a gallon, which is unbelievable. It was just the cleanest car, and the Miata was the dirtiest car at that time. 1 year after the Miata came into the country, it wouldn't pass smog. The reason you see those sheds behind me is because back then, actually General Motors, Ford, Chrysler had offices at the state test facilities, and Well, what happened is back then our product was called the Econo valve. It was the mechanical dyno valve. It's come a long way since then. Now it's fully computerized and upgradable through a flashable chip that's on the computer itself. But back then it was mechanical, so it had to be hooked up to every linkage of every vehicle separately, and it was hard to make that work on every vehicle. So we've come a long way since then. But what we did do, since we tested back in '93 with it, we actually took the same vehicle, the '93 Taurus, and got ULEV. Remember, this is back in 1993, and we got ULEV for the year 2020, which is ultra-low emission vehicle, which is really just natural gas and propane. And they didn't think that gasoline was going to be around for the year 2020, so maybe it still might not be around, we don't know. But the thing is, on the Horiba equipment, which is the really expensive computers that analyze all the data, they were getting minus zeros on the printouts. So the ERB came in and closed the lab down for 4 days and calibrated the equipment and found out that there was nothing wrong with it. So there was a problem because the data was saying that the air was cleaner at the tailpipe than it was around the ambient air. And sure enough, that's what happened. The big three were polluting. They were allowing the air to be released prior to going all the way through the tailpipe. They were trying to delay the process of the emissions because it was a 25-minute test, and then after that, after 25 minutes, they could then release it. So through a charcoal canister or putting the emissions back in the gas tank, they had all kinds of tricks to get around to get the executive order so they could then sell the vehicles in California. So the way it turned out is because of the way this whole thing happened, the Econo valve actually blew the whole thing open, and there's a reason why these sheds are even used today. It's because the big three were cheating, and they got caught with their pants down, and the dyno valve or the Econo valve back then is what exposed them. This is the data acquisition room. This is the computer, the Horiba equipment behind me. So what it does is it gets all the data. Let's say we do from one engine, it gets all the data and it records. To get certification on some products, you might have to test for 1,000 hours. In this room, in this whole room here, it's verification of engines and aftermarket products for the diesel products. What we have here is 2 engines behind me on 2 dynos. These are engine dynos. To my left is a Caterpillar, to my right is a Cummins. As you see towards the left of the building, you'll see like 4 to 6 engines. Those are engines that are different types from different manufacturers. When you certify a product, you have to certify a diesel product with a certain classification of engines. So then, if right now there's a Cummins and a Caterpillar, so those are one of the 2 most common engines. So what we do is certify the dyno valve pro here. The dyno valve pro is the same as the dyno valve, but what it does is, if you look at the way diesel engines are, they have a tube that comes out of the valve cover, and it goes to the concrete, spews out all kinds of oil and puke. What happens is, like if you look at a bus, Detroit diesel bus, it puts out a quart of oil every 80 miles. This oil is not burned, it just goes on the concrete and just spills everywhere and eventually gets up into the water table. If you look at a Kenworth, the Kenworth 18-wheeler, those put out about 2.5 gallons of oil every 5,000 miles. That's just a bunch of wasted oil because that puke tube is just a bunch of undated vapor along with a whole bunch of oil that just gets spilled out there. What the dyno valve pro does is the same as a dyno valve. It takes the vapor from the crankcase and reburns it. But because diesel fuel is so much dirtier, it then takes the blow-by tube, which is considerably bigger, and then goes to an oil separator. It draws up the oil and the vapor. Oil settles, it gets cleaned through a filter, and then goes through a check valve back into an inspection plate inside the crank of your diesel engine. And so the full oil amount is recovered. The vapor then is separated, goes through the expansion chamber, goes through a manifold, and then goes back to get reburned with the fuel. Some of it goes back with the diesel fuel, and the stuff that's a little dirtier goes through the air filter. So when you change your air filter, it actually cleans that portion out too. So we seal the diesel engine, which is something they should have done a long time ago. Just for a statistic, a couple of years ago, I think it was 2 years or last year sometime, the consumption of oil in the world is, I believe, 9,760,000,000 gallons of oil per day. That's a huge amount of oil, and if we could recover 20 or 30% of that, you can imagine how drastically we could lower that number. Also, if we could seal that engine, all diesel engines, then it won't puke that into the oceans, and it'll save a lot of coral reefs, and also save our environment. Anything you do outside in the air eventually settles to the ground and eventually ends up in the water table, which eventually ends up in the oceans. So our part is to try to correct that. That's what we're trying to do. Thank you so much for taking this virtual tour.